All right, so we want to take something, given a vertex and another point, can we change it into this equation right here, what we call vertex form. Now, vertex form shows you several things. One, it shows you the vertex. Remember, H and K, that's your vertex. Where that minus inside the parentheses has nothing to do with H. That's a separate issue. That's part of the original formula. Then we also see the A value, which establishes the pattern and tells me how to using the 1A, 3A, 5A method of graphing, how to graph the function, controlling whether it opens up or down. It's that whole stretch or vertical stretch or shrink. Also can include a reflection if it's there. So we're going to start with, let's start with the algebra way of doing things, at least on this question. So we've been given a coordinate, x minus blank squared plus blank, and we've got a equals y. Okay, so we start with this, and we've been given 5, 7. Now what are we going to do with this thing? Well, guess what? We're going to use it for x and y. So we're going to come over here to this equation, and we're going to replace. So 9 equals a 3 minus 5 squared plus 7. Now, before we go further with this, I'm going to be asking you to simplify this purple box. Now, there's a real reason I do that. It's because sometimes kids make mistakes. But you need to be able to look at that and go, oh, well, 3 minus 5, that's negative 2. Negative 2 squared. Okay, that's positive 4. So the box turns into 4a. 4a. And then, of course, we've got the plus 7 on the outside here and the 9 over on the other side. And then we can start solving this, right? We'll start solving it by subtracting a 7, getting myself 2 equals 4a. And then we can continue by dividing out the 4 and finding out that a is 1/2. So now we can write our equation in vertex form. We have the a value of 1/2. We have the vertex at 5, 7. So here is my vertex form on this particular equation. Now that I did the algebra to solve. There will be times when we graph these things and you'll be able to tell that a value without having to solve. You'll be able to tell it straight from the graph. Okay, so part B here, we got another one. We don't know what a is. We're going to figure that out here. We know that we've got negative 4 goes here, and then the negative 8 goes on the outside, right? That's your vertex. And then we get to use the other coordinate, the 0, 40. 0 for x, 40 for y. Now we're just going to go through the process of figuring out what's in this purple box, and that would be 4 squared is 16, so that would be 16a. Of course, on the outside you got your minus 8, and on the other side you've got your 40. And so we can push this to the other side, giving me 48 equals 16a. And now we can do the division. So now we know that a is 3. And we can write our equation, y equals 3, parenthesis, x. Now remember, this had that minus minus, so that's another way to say plus 4 squared, and then the minus 8 on the outside. So there is my final overall equation for part B. So I don't really totally agree with this particular question because the height of the ball, the height of a thrown ball is a quadratic function of the time it has been in the air. This ball literally could go straight up and come straight back down. It has nothing to do with the path that it traveled. Now, yes, if you throw a ball, it will follow a parabolic path, but that's not, so this is a little bit misleading. The graph of the quadratic function is a parabolic path of the ball. It is not following, I mean, literally the ball could go up and come back down. You're measuring time this way, and you're measuring the height. So it literally has nothing to do with the path of the ball. Okay, that's a completely different question, but I do understand that people get that confused. So let's see here. The vertex is at the point 120. Okay, so if we do what we did before, we don't know the a value, but we do know that we have something minus 1 squared plus 20. Okay, and then of course we have another point, a 0, 4. So we're going to plug that in, 0 for x, 4 for y. We'll figure out what's in this box right here. That would be, let's see, on the inside here, we got negative 1, and we square that, we get positive 1. So that's positive 1a plus 20 equals 4. And then, of course, we can move that to the other side. So a equals negative 16. So now we have our equation, negative 16 x minus 1 squared plus 20. Okay, so that's what we call vertex form. But then they also, so not only did they ask for vertex form, but then they also said, what about standard form? Standard form, how do we do that? Well, that's where we have to follow the order of operations. So they're asking me to go one step further. Right? Remember, we've got negative 16 times x minus 1 times x minus 1 plus 20, right? Anytime you square something, you're multiplying it times itself. And I would want you to start here with the FOIL. And you can do it in several ways if you want to line them up vertically. And try this, the old elementary school style method. That would work. You know, negative 1 times negative 1 is positive 1. Negative 1 times x is negative x. X times negative 1 is negative x. X times x is x squared. And then you could add those together, x squared minus 2x plus 1. That is not the only way you could do that, right? If you want to do a box, you can do a box, x minus 1, x minus 1. And then you could fill in the box, x squared minus x, and a plus 1. And then you could start matching things up. Get the same exact result that you had here. If you like to draw arrows, you can do firsts, outsides, insides, and lasts, just like you did in Algebra 1 maybe. Next on our list is the distributive property. We want to distribute the negative 16, right? That negative 16 is now going to get distributed to everything in the parentheses. Everything in the parentheses. Giving me negative 16x squared plus 32x minus 16. And then, of course, you have the plus 20 at the end. Last but not least, we have to look for like terms. Like terms, and we have a couple right there. So, final standard form answer, y equals negative 16x squared plus 32x plus 4. And if you look back at the picture, that 4 is your y-intercept. So y-intercept equals 4. And ding, 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 look right there. When the object was launched from the person's hand, it was 4 feet off the ground. Remember that the x value of any y-intercept is 0. So that is the coordinate 0, 4. You can't see that so easily from the vertex form. Now, what can you see from the vertex form? Well, if somebody asked me what's the max height of this ball, my answer is going to be 20 feet. If the next person asks me, well, how long did it take to get there? Well, I'm going to say 1 second. eventually we're going to ask questions like, well, how long did it take to hit the ground? As you can see in the picture, a little over 2 seconds. And we will find out in a future video exactly how to find that time. So next slide. Function g is a translation of the parent function, 1 unit left and 3 units up. What is the equation of g? Okay, so if you're given a picture and I should be able to look at this picture and come up with some basic information. Like, for instance, I can see that the vertex is the point -1, 3. Well, I can put that information into my equation, right? -1, 3. But then again, I don't have to do algebra here. Remember my 1A, 3A, 5A pattern of graphing? Well, right there, I just found the value of A. It's a +1. The graph went up, and as you moved 1 to the right, you went 1 up. If you can easily tell that on the graph, then just write the equation. You know, I don't need to do algebra for that. Now, if I wanted to do algebra, if I wanted to take the coordinate 0, 4 and do that, I could. But I literally can see that it's a +1. Now, some people will say, well, Mr. Stailey, if it's a +1, why would I need to write that? Okay, I can go with that. And you got the double negative there, so that turns into a plus. So here's my equation in vertex form. Now, I think they poorly asked the next part. It says, write the quadratic function in vertex form, and what they should have just said was, and write it in standard form. Okay, all right, that makes more sense, but they kind of made it seem a little bit strange. Now, I'm sure you can probably see in this particular question that after I do the foiling, right, whether I do x plus 1, and 1, and an x, and an x, and an x squared, and I line things up and get x squared plus 2x plus 1, carry down the plus 3, you'll notice that there's no distributing that I have to do. Like the last question, I had to distribute the -16. Well, since this is a 1 out in front, there's nothing to distribute. Multiplying everything by 1 is pretty boring. Doesn't do a whole lot. I do see some like terms that needed to be added together. So, x squared plus 2x plus 4. So there is my standard form version of the same thing. So, as I was saying, if you can tell from the picture, I don't think there's a necessity to do algebra. When you look at this and you're like over 1 down 4, then you automatically know that the A value is -4, and that's the first part, you know, after the y equals, before you get to the parenthesis. Of course, now we can see that the vertex here is 3, 4. So I know that this is x minus 3 squared and a plus 4, because it's always backwards of what you see inside and exactly what you see outside in terms of your shifting left and right and up and down. So I don't see a real need to do, you know, tons of algebra here, at least on that one. But if it makes you feel better, you can always do algebra. That's a great backup plan. However, when you get to this question and you're looking at it and you're like, I don't know what that A value is. That's a question mark. Well, now you better pick a point. Now, I don't care which point you pick, whether you pick that point or that point, but you're going to have to do algebra here because it's not going to be so obvious. So, oops, sorry. the vertex is at the point 2, -1. So 2, -1. And then, of course, I'm going over to 5, 2. So I'm using that point 5, 2. And my vertex at 2, -1. And so now I can figure out that we have what? Let's see, 3 squared is 9, so that would be 9a minus 1 equals 2. And then we move that over to the other side, which would be 3 equals 9a divided by 9 divided by 9. A equals 1/3. So now we know the equation. I wouldn't have known that right away when look at that picture. It's kind of a it's an iffy fraction. And so I'm going to have x minus 2 squared and a minus 1. There's my final equation for this particular parabola. I did have to do some algebra. Okay? Let's see what else we got here. So can we look at these and tell? Sure, we can say a equals positive 1. Can we look at this and tell? Sure, a equals -1. So sometimes you can look, you can just identify, you don't need to do a bunch of algebra. You can look and say, oh, okay, let's see, I'm coming over 1. That's a equals -2. Here, not so much. This is going to be an algebra question. So I'm not going to work through that, but you got to look at them and say, oh, well, that's obviously this, that's obviously, I mean, if you can tell from the picture, use it. If it's not so obvious, you're going to have to switch to algebra. So right there, over 1 up 3. Obviously, that's a 3. Over 1, ooh, no idea. This is an algebra question, okay? So please make sure that you if you can, if you don't have to use algebra, fine. But if you do, make sure you use it. All right, next lesson.